All right, let's take a look at the questions from checkpoint 14. So this first question here, we're trying to find the social gain. So that is the sum of the two surpluses, so the producer surplus and the consumer surplus. So before we do that, we need to find the equilibrium conditions. So equilibrium happens when basically supply and demand are basically balanced. So at what price conditions, um, yeah, we're going to the supply and demand conditions is going to be the same. So to do that, I'm going to take so this is the demand curve, this one here, and my supply curve is given by this equation. Basically, I'm going to take those equations and treat them like a system of equations and solve them. So let's go ahead and do that first. So P equals 128 over, and then I'm going to substitute in for Q this other expression. So 0.5 P minus 1 plus 1 squared. That's it, right? Okay, good. So these terms cancel. So what do I have now? I have P equals 128 over 0.5 P squared. So that becomes 1/4 P squared. So this becomes 1/4 P cubed equals 128, or P cubed equals 512. And then finally, P, the cube root of 512 is 8. So here's my price point, $8. So from there, yeah, so what's the supply that goes with that? So at a price point of $8, how many burritos am I supplying at that? So yeah, the number of burritos per hour, I guess, is my supply, how I'm representing this. So Q equals 0.5 times P. So the price point is $8 minus 1, that's 3. So this is my price point. So these are my equilibrium conditions. So at a price point of $8, we're going to supply 3 burritos per hour. And since equilibrium, we're at equilibrium, what that means is that basically I'm supplying that many, and those are going to be bought. That's how many are going to be demanded by the customers. Part B. So now we're going to find the social gain. So how do we find the social gain? Basically, we have to find the consumer surplus and the producer surplus. So let's find the consumer surplus first. So how do we find consumer surplus? So that comes from this integral. So the integral from 0 to whatever my supply point is that I want to integrate to, of the demand curve with respect to Q. But it's surplus, so basically I don't want all the area underneath that demand curve. I want basically I'm looking for the area between the demand curve and this is the time of the lesson where it freezes. So I'm looking for the area between the demand curve and um, basically what the customers actually spent. So think about it this way. If they're going to buy 3 burritos per hour at a price of $8 per burrito, that basically tells you what this term is, that P bar Q bar. That should be $24. So for the rest of this, I'm going to need an integral, but I can find this part pretty simply. So let's start filling in some of these details. I'm going to integrate from 0 to 3 of my demand curve, which is the very first equation I gave you. So let's actually put it in terms where I can integrate it maybe in a more friendly way. 128 times q plus 1 to the negative 2 dq. And then minus p bar is 8, q bar is 3. All right, how do I integrate? Or what's the antiderivative of 128 times q plus 1 to the negative 2? We can use power rule on that. Really, you could use, I'm going to go ahead and kind of bypass integration by substitution because our inner function, q plus 1, the derivative of that inner function is 1. So I'm going to kind of bypass the integration by substitution. If you set this up that way, that's totally fine. But I'm just going to go straight to power rule. So if I take the antiderivative, I'm going to add 1 to that power. That becomes negative 1. So 128 times q plus 1 to the negative 1. And then I have to divide by that new power. So divided by negative 1. And I'm going to evaluate that across the interval. So from 0 to 3. And from that, I'm going to subtract 24. So what happens when I plug in 3 to that? Actually, let's not do that yet. Let's kind of clean this up. So negative 128 over q plus 1 evaluated from 0 to 3 minus 24. When I plug in 3 for q, I get negative 128 over 4. So that'll be negative 32. Let's drop an equal sign, negative 32. When I plug in a 0, I get negative, so minus negative 128, so plus 128, then minus 24. So I wrote down what that comes out to be, and that is $72. So the consumer surplus is $72. So that's the money that stays in their pockets because they might be willing to pay $72 more, but I'm not charging them for that. So consumer surplus is $72. So the next thing we want to find is the producer surplus. So how do we find the producer surplus? So that comes from this integral. So the integral from, again, 0 to q bar. So we're going to use basically our same interval. But now we're looking for basically what's the right way to say this? Well, let me write down the interval first, and then we'll talk about kind of symbolically what this means. So we're looking for the area between these two curves, basically this horizontal level for what our price point represents and what the supply curve represents. So do we have all these pieces? I believe so. We have the price point, that's 8. So let's start filling in these details. So the integral from 0 to 8 of p bar, that's a constant 8. Do we have the supply? So what's the supply curve here? Supply curve is here. Q equals negative or 0.5 p minus 1. But we have to be careful. This calls for the supply curve, but I don't have the supply curve in terms of Q. I have it in terms of P. So I have to do a little manipulation here. So let's solve this equation here for P. So let's move the 1 over. Q plus 1 equals 0.5 P. Multiply both sides by 2. I get 2Q plus 2 equals P. So that's what I want for the rest of this. 8 minus 2Q plus 2 dq. All right. Let's go ahead and distribute that equal sign. We're not integrating it from 0 to 8, 0 to 3. So the integral from 0 to 3 of 6 minus 2q dq equals, so let's take the antiderivative now. 6q minus 2q squared over 2, so q squared, over the interval 0, 3. This becomes 18 minus 3 squared, which is 9. And then minus, if I put 0 in for those, I'll just get 0. So this comes out to be 9. So I got a consumer surplus of $72, a producer surplus of $9. That means my social gain is equal to 72 plus 9, which is $81. All right, that's all for question 1. How about question 2? All right, so the annual revenue earned by Walmart in the years from January 2000 to January 2012 can be approximated by this rate here, where T is the number of years since January 2000, and R of T is measured in billions of dollars. I want to find the revenue earned by Walmart in this 12-year period. So how do I find this revenue? So if I know the rate, this is a continuous revenue function. If I know this rate, then I can set up an integral to basically find out what the accumulation is over this rate. So it's a 12-year period. So I'm going to integrate from 0 to 12 because I want to start at January 2000. And I've told you that T stands for the number of years starting at January 2000. So I want to integrate this function. 176 times e to the 0.079t dt. So what's the antiderivative of 176 times e to the 0.079t? So if you think about the derivative of exponential functions, the derivative of e raised to some power is e raised to that power times the derivative of that power. So if I take an antiderivative, I'm going to divide by that power. So my antiderivative will look like this. 176 over 0.079 e to the 0.079 t evaluated from 12 to 0, or 0 to 12. So for now, I'm going to keep everything unapproximated. So e to the 0.079 times 12 minus, what happens when I plug in 0 for t? That's going to become e to the 0, which is simply 1. So what's left is just 176 times, or divided by 0.079. So this right here, if I now take this to my calculator, I get this value that I wrote down for you. 3521.21. And what did I say that was measured in? That is in billions of dollars. So over this 12-year span, Walmart made about $3.5 trillion, or $3,521 billion. And that is all for checkpoint number 14.